close this out. Let me check one more time. Okay, we got it. I'll check again. I'll check attendance again around the 15-minute mark, and we're going to go ahead and start off here. All right, welcome scholars. Okay. Let's see. I hope everyone is doing well, right? So we are like rapidly approaching the home stretch here, right? This is the end of week 11, so that means I just checked. So next week we do have exam 3. I did schedule for it to become available this upcoming Sunday at 11 a.m. It'll be due the following Sunday at 11:59 p.m. Right, so that's where you can earn over 90%. After next Sunday, the highest you can earn is a 90 on that assignment. You know the usual spiel there. So, next week, I'm just going to be on the call just to answer questions. I'm probably just going to log in just to take attendance. I'll probably be updating some files and things associated with you all and kind of going through the people that I haven't seen in a while. I'm probably going to submit their names to be like purged or something of that nature. So if you have more than like 2 absences, unexcused absences, you could be potentially purged, but I try not to purge students that actually intend to stay. So I try to reach out. I'll try to reach out in some form or fashion. So if you just know that you have more than 2 unexcused absences, you might want to like sit on the call next week and just make sure, because I'm going to be going through trying to connect with students that have 2 or more absences. And if I can't reach out for them, I'm probably going to submit their name to be like, hey, this person has, exceeded a number of unexcused absences. You might want to purge them. But if you say something, then I'll just make a note of it and I'll update it so that you're not automatically purged, right? So we can anticipate something like that next week, because that's just when I told myself that I would do it. That's when I'll have the focus and everything I need to do it. Yeah, I can't think of anything else. So for today, what I feel like is an appropriate move is to, so let me see, exam 3, I think is focused on chapter 6, right? So I think we introduced 6.3 on Monday. So let's take some time today to go through as many homework questions as we can. 6.3 covers geometric sequences and series, right? So geometric sequences, the only difference between geometric and arithmetic. So I think like 6.1 was on sequences and series, just a string of numbers, generated in one form or fashion. 6.2 covered arithmetic sequences, where in those sequences, we had what's called a common difference, where we were adding the same thing at each step, right? So we were given an initial term, and then we were adding the same thing each step. A very famous like arithmetic sequence, let me see, is it arithmetic? Actually, it's not arithmetic. It's more geometric, if anything. It's the Fibonacci sequence, right? So like where you start with the first term is 1, and then you double that. So let me see. It really goes like 1, 1, and then 1 plus 1 is 2. Heck, it's not even geometric, because you're not multiplying the same thing each time. It's not really, it's more recursive than anything. But a famous sequence is the Fibonacci sequence, where it goes 1. The first 2 terms are 1 and 1, and then 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8, yada, yada, yada. So it basically keeps adding whatever the previous result was, it adds to the next one. And it leads to this consequence. It's called like the golden ratio, or the golden mean. And the reason it's so famous is because this golden ratio is like found everywhere in nature. Like if you took the length of, like if you look at your hand, right? And you took the length of, like, if you look at your middle finger and you see how it's like broken into what, 1, 2, 3 sections or whatever. You have the tip, the middle, and then the whatever. I don't know the names. But if you took the length of the tip of your middle finger to the length of those 2 regions, that like the length of the tip divided by the length of the 2 is the same as the length of the 2 divided by the length of the 3, which is the same as the length of the 3 divided by the length from the tip of your middle to the base of your palm, which is the same as the length of your hand divided by like the length of your arm, and it just keeps going. Like the length of your arm divided, or the length from the tip of your finger to your elbow divided by the entire length of your arm, like it just keeps going and going and going, like this golden ratio. That's one place where it's found. It's like in a lot of natural structures. They're like seashells, like everywhere. It's everywhere. It's kind of wild, and it's really interesting, and it leads to like to some like very kind of like kooky conclusions. Like if you look at and I know I'm kind of rambling a little bit, but it'll be okay. But if you look at like look at and this is just something, I don't even know how logical or sound this next statement is, but like if you were to consider all of your molecules, right? And just think about your molecules, and what are the odds that if you just looked at if you just took your molecules and just randomly threw them together, what are the odds that they would come together to form you, right? There's like 1 in a trillion or whatever, some astronomically large number. The chances of molecules randomly coming together to create all of this is like practically 0. So then if the chances of molecules randomly coming together to make all of this sentient life, if those odds are practically 0, then that implies that a lot of this stuff is not random. It implies that it's intentional, which means that it kind of points towards this notion of like intelligent design when you think about life, right? It points towards this notion or idea if you just do sheer numbers. And it's just a bunch of like kooky like conclusions that kind of come out like that, so it's really interesting, and so it comes out of some of these topics that we're talking about. But anyway, so let's focus and get on task. And again, I'll check attendance for people that are coming late in the next 5 minutes. We're basically around the 15-minute mark. So let's see. This question comes from 6.3, question number 1 from the back of the text. It says, determine whether the sequence is geometric. So I think we mentioned that arithmetic means that we're adding the same thing each step. So then with geometric, that means that we're multiplying the same thing at each step, right? So then with this question, we ask ourselves, are we multiplying the same thing at each step? It looks like we're multiplying by 5 at each step. And if you just do a quick confirmation, it does work out. Yeah, so I'm going to hit yes for geometric and go on to the next question, or the next part. The common ratio. So common ratio is we're multiplying by 5 at each step, so the common ratio is 5. Okay. As always, if anything is not clear, feel free to either unmute yourself, which is my recommendation to get my attention, or type in the chat. I do check the chat periodically. Same thing here. To determine if this is geometric, we ask ourselves, is there a common ratio? It looks like first we multiply by -4, -4. Yeah, it looks like we're multiplying by -4 at each step. So the sequence is geometric where the first term is 3 and the common ratio is -4. Okay. Determine whether the following sequence is geometric. If it is, find the first term and the common ratio. So with this one, it's a good idea to list out maybe about 4 or 5 terms, like the first few terms. So let's do that. I'm just gonna do it here. So for instance, when n is 1, we're gonna get 6 to the power of 0, which is 1, right? When n is 2, we're gonna get 6 to the power of 1, which is 6. When n is 3, 6 squared, it looks like we're multiplying by 6 at each step because we get 36 and then yada, yada, yada. So if we are multiplying by 6 at each step, then I think the first term in this sequence is 1, and the common ratio, we're multiplying by 6 at each step. Okay. Hopefully this makes sense. Same thing here, right? If we want to determine if it's geometric, let's just look at a few of the terms, the first few terms. So when n is 1, we get 1. When n is 2, we get 5, right? When n is 3, I think it's the same kind of deal, right? So the first term is 1 and the common ratio is 5. Let's go with it. Okay, kind of very similar to the previous. Let's see. So with this one, we should write it out. I'm just avoiding opening up the notebook because I've just been lazy. But I think in this one I need to do that. What's his time? Let me do this one and then I'll check attendance after. Let's start by getting a copy of this guy. Okay. Let's take this. I'm gonna drop it right here. Okay. Let's see this right here. All right. So let's see the first term. So when n is 1, right? We're going to have 6 times 1 squared plus 3. I want to copy all of this. Copy. And let's start off with like 4 terms. Whoops. Oh, I hate when it does that. Okay. Let me see if I can get rid of that thing. Yeah, I can. I just made that too big. Let's copy. We can delete that. I think we're okay. So we'll do this. Let's try to go 4. As long as the numbers don't get too outrageous. Okay. So when n is 2, 3, 4. 1, 2, 3, 4. Okay. So then 6 plus 3 is 9 is the first term, or the first term. 4 times 6, 24 plus 3. This is 27. All right, times 3. Let's do another one. 9 times 6 is 54. So 57. Right? So it's not geometric. Because at first we multiply by what? Like 3. But then 27 times 3 is not 57. So it's not geometric. Okay. Let me submit this one and then I'll check attendance. Let me see. So it should not be geometric. All right, let's check Zoom. Let's check on you guys in Zoom. Okay, let's do it like this. Thank you. Okay. Let's get back to it. Okay, so on to the next one. So let me see. It says find the first term a1, the common ratio r, and the nth term an for the following geometric sequence. Okay, let's take some notes on this one. I just feel like we need to take some notes here. Okay. I think this will be in the space. We can work here. Okay. So we're working with a geometric sequence, right? So now let me see. Off the top of my head, I don't remember the recursive formula, but let me see. That was the sum of the first n terms. Okay. I think for the nth term of a geometric sequence was the first term times r to the power of n minus 1. All right, I think that's what we said. Because when n is 1, you just get a1. When n is 2, you get a1 times r, and then you just keep multiplying by r at each step, right? So this will take us to any term in a geometric sequence. So this is the nth term of a geometric sequence, okay? So I think they gave us the first term. Common ratio looks like it's what, 5, right? You can find that quickly. 10 divided by 2, 50 divided by 10, so the common ratio. So then for the nth term, I think we have everything that we need. The nth term is going to take on the form 2 times 5 to the power of n minus 1. And I think we can leave it like that, to be honest. That looks good. We could confirm, we could confirm that this general definition works for all of these. I'm just going to submit it just for the sake of time. 2 times 5, the first term. So it's doing that thing. First term we get is 2. That's given. You just look at the sequence. Okay. Common ratios is easy. 10 divided by 2 is 5, right? And we're multiplying by 5 at each step. And then we got 2. Let me think about it. Simplify. It says simplify your answer. I'm going to try submitting it in the following way: 2 times 5 to the power of n minus 1. It might not accept this because we might need to simplify it. Okay, but it did. So that was going to be the more simple way to submit it. We could have written this as 5 to the n divided by 5. So then you could have put 2/5 times 5 to the n, and you get the same result. But this was much easier to submit than doing all those unnecessary manipulations. Okay. So what, 5? Looks like we're multiplying by what, -5 each time? Hey Siri, what's 1.5 times 5?
1.5 times 5 is 7.5.
Hey Siri, what's that answer times 5?
7.5 times 5 is 37.5.
Okay, so it does look like we're multiplying. So the first term, it looks like we're multiplying by -5 at each step. The first term is 0.3. Okay. And then the common ratio, I think we said was what, -5. Okay. All right. So then the nth term is going to take on the form of 0.3 times parentheses -5 to the power of n minus 1. Yeah. Okay. And again, if anything is not clear, let me check on you guys in Zoom. Hopefully we're all aboard and we're not all bored. I know this stuff can kind of be a drone. I try to bring a little bit of energy to it with just interesting stories, whatever I can find interesting, or just a little bit of enthusiasm. But yeah, if you think I'm boring, wait till you get to some I don't want to bash nobody. I don't want to throw no shade, but it's different. You got to research your professors and try to get as close to a style that you feel like you resonate with as possible. Many people don't resonate with me, and vice versa. But anyway, that's neither here nor there. Find the first term, the common ratio, and the nth term. Okay, we're given that it's geometric. Let me see. We are multiplying by pi to the power of 7, right? At each step, because if you keep adding 7 to the powers, right? So the first term is pi to the power of 13. So I'm going to type pi to the power of 13. Okay. Common ratio, again, we're multiplying at each step in the form of pi to the power of 7. Okay. So then the nth term is going to be the first term, which is pi to the power of 13. And we get out of that power, then we're going to say times r, which is pi to the power of 7 to the power of n minus 1. So then that's going to turn into pi to the power of, basically it's 7 times n minus 1. So it's going to be 7n minus 7. That's one way we can, and we can do other manipulations, but this should be it. Okay, let's see. Because another thing that we can do, so to the power, a power to another power you multiply. So we might need to simplify okay, so we can add these guys, right? If we say one exponent base pi times another exponent base pi. So that means we can condense this down even further. We would add these powers. So then 13 plus -7 is what? 6, a +6. So this is really plus 6. We just needed to simplify a little bit further. We didn't simplify. I think that's it. Let's go with that. Let's verify these terms first. When n is 1, notice we get pi to the 13. When n is 2, 14 plus 6 is 20. When n is 3, 21 plus 6 is 27. When n is what? 4, 28 plus 6. Okay, this checks out. We just needed to simplify further by, we just needed to simplify further. So what we had was correct. We just needed to go a little further. Okay, use the formula for the general term of a geometric sequence to find the indicated term of the sequence, given the first term and the common ratio. We want the 8th term. Okay. So the 8th term is going to take on the form of the first term, which is 2, times the common ratio, which is 2, thank you, to the power of n minus 1. So it's going to be to the power of 7. So then ultimately it's going to be 2 to the power of 8. I know 2 to the 5 is what? 32, 64, 128, 256. Let's try 256. Right? It was what? 2 to the 8. I think it was 8. Whatever the number was, I forgot just that quick. Because I don't know, I'm not even thinking about it. All right. Find the 28th term of a geometric sequence whose the first term is this guy, whose common ratio is a -1/2. Let's see. I'm going to go ahead and write this. Let's write it out. So also next week, while we're working on the exams, you can ask me questions about anything that's on Pearson, even your current exam, right? Because if you don't like your final score, you can always retake the exam, and it's going to be a different exam. It's going to be the same content, but a completely different exam. That's why I don't mind the structure, the structure that I have created, right? Where you can ask me questions, and because it changes each time, you really got to know what you're doing when you get into that. Anyway, let's get a copy of this guy. But I don't mind like answering specific questions about anybody's exam next week, like even while it's live, like that's okay. Let's see. Let's take a copy of this. I'm gonna drop it right here. Good. Like that. And this one. Boom. Okay. All right, that looks good. All right. So if we're working with a geometric sequence, then it's a good idea. It's a good idea to start with the nth term. So we got the nth term. Come on. Nth term of a geometric is going to take on the form a1 times r to the power of n minus 1. Okay. So then we're asked to find the 28th term. So the first term is 7,000. Our R common ratio is a -1/2, and it's going to be to the power of 28 minus 1. I think I'm just going to use the calculator. That just seems like the simplest way to go about this. This one, yeah. All right, let's clear out my, do I need to? There we go, okay. So, let's go 7,000, parentheses, negative, -1/2, close parentheses, hat, open parentheses. We can just do 27, close parentheses, all right? Hopefully that makes sense. I just typed it in the calculator and output, just really small. 28th term. Okay, let's hop back over to, back over to this here. It's in 9 decimal places. Come on. All right. let's so that means that what we have is fine. We just got to put the final thing in properly. Because that's -5, that means we need to move the decimal to the left 5 places. So let's give it a go. All right. So then we're going to have, let me see, -0 point. Now we're going to have 1, 2, 3, 4. So now that gives us our 5. So we need to go out 4 more. 1, 2, 3, 4. The fourth place would be that 4. To the right of the 4 is a 0. The 0 says to stay the same. So we're going to put 2154. 2154. Cross our fingers, and God is good. Because I was like, that's a weird one, but that's just how it played out. All right. That's just how it played out. Let me check on you guys in Zoom for a moment. Okay, nothing in the chat. We got any latecomers? We do. Let's see. This one and this one. Okay. Let them in. Thank you. Let them in. Share the screen. Start the broadcast, and let's keep the party going. Okay, let's go on to the next one. Use the formula Sn to find the sum of the terms of a geometric sequence. Find the sum of the first 5 terms of the geometric sequence. Okay. All right, this is a good one. We're definitely going to take some notes here. Let's see. This. Yes. That's fine. Oh, I like that. That's fine. Okay. Drop a copy here. Let me see how much space do I have. Is that enough space? Let's give it a go. All right. So we want the sum of the first n terms. Now, let me see. Okay, I don't really remember the formula for the sum of the first n terms of a geometric sequence, but I remember how to find it. So I'm going to do a quick derivation on the side. So, for instance, if we're thinking about the sum of the first, if we're thinking about the sum of the first n terms, come on, of a geometric, that's going to be the first term. The second term is going to take on the form a1r. Let's do another one, a1r squared, until you get to a1r to the power of n minus 1, right? So then if we multiply this by r, we're going to say, consider the same thing, but we're going to multiply by r, and that's going to give us a1r, a1r squared, a1r cubed, and I think it's going to be a1r to the power of n, all right? So then if we say line 1 minus line 2, we're going to get Sn minus r Sn equals, now if we subtract the first line minus the second, this is going to cancel this is going to cancel this. Ultimately, all that's going to be left is the first and the last. Okay, and we're going to have a1 minus a1r to the n. Okay, I think we're in a home stretch. So if we factor and divide, the sum of the first n terms is going to take on the form a1 times 1 minus r to the power of n all over 1 minus r, right? So like, to me, it's easier to remember derivations than to remember formulas. Like trying to remember this rotely is like, you know, it's just, there's no context, there's no like, it's a challenge. But I remember the backstory. I remember the dialogue. This is much easier for me to remember. You just start with the sum of the first n terms of geometric. The trick was to consider the exact same sequence, but then you multiply by r in the second step. And then when you say the first minus the second, you get something like this. And then through algebra, you get this, right? That's, for some reason, that's just easier for me to remember versus just trying to remember this guy. I'm like, no. I often default to something like this first and then conclude here. Okay, so that's what we needed anyway. So let me just copy this guy. Copy. And we're going to paste that here. Okay, and I think I'm actually going to shrink that down. Okay, so that's the sum of the first n terms of a geometric sequence. And I'm going to do that in green. That's fine. And then it also helps. We also would need something like the nth term of the geometric is going to take on the form of the first term times r to the power of n minus 1. Okay. All right, so those are the two pieces of information that we more than likely will need. We got a solid 10 minutes. Let's keep it going. Use this formula to find the sum. Find the sum of the first 5 terms. Okay, so we have the first term. We need the common ratio. It looks like we're multiplying by 1/4 at each step. So it looks like that's all that we needed. Let's plug that information in. So if we want the sum of the first 5 terms of this geometric, that's going to be 3 times 1 minus the common ratio is 1/4. N is 5 in this case. Okay. Over 1 minus 1/4. I think I'm gonna just use my calculator for this one, for the remainder. Okay. So let's see. We have 3 parentheses, 1 minus, let's do parentheses 1/4. Oh, I hit clear, didn't I? Okay. 3 parentheses 1 minus, that's not a minus, 1 minus parentheses 1/4, close parentheses, hat to the power of 5. So then we want to close off that guy. We're going to say divided by, I'm going to do another set of parentheses, 1 minus, that's not a minus, 1 minus 1/4. Okay. All right, I think I have it typed in properly. That to the power of 5, closed off that. That's okay. Let's go with it. Okay, the sum of the first 5 terms, so we get something like that. So then let's hop back. We want this guy. Okay, let's hit math as a fraction. Let's go with it. I mean, that's about the best we can do. 1023 over 256. Ooh. Well, look at that. All right. All right. Next question. All right, find the sum of the first 15 terms. Okay. Yeah, similar to what we just did. So it should go a lot faster. So just since we have our formulas ready to go. Let me see the time. I might either this will be the last one, and I might do one more after this. It shouldn't take us that long to do this one because it's basically a repeat of what we just did. At least it looks like it is. Sometimes it's not that straightforward. Oftentimes it's not that straightforward. Let me see if I can paste. Okay, that's what I want. I want that in green. It doesn't hurt to go ahead and write the nth term. It's going to be a1 times r to the power of n minus 1. Okay. So then here, they're asking us to find the sum of the first 15 terms of the geometric sequence. Okay, so we need the first term, which is a -3/2. 1 minus the common ratio. Let me see. We multiply by what? 2? We multiply by -2 at each step. So the common ratio is -2. N is 15 in this case. Over 1 minus -2. Okay. So again, I'm just going to put this in the calculator. It says round to 2 decimal places. Okay. So I'm going to isolate the top divided by the bottom. So I'm going to do an open set of, let's clear. Okay, the top, first we have this, I'm going to just do another set of parentheses, -3/2. Okay, close parentheses. I'm going to open another set of parentheses. I'm going to say 1 minus another set of parentheses, -2, which is this one, -2. I'm kind of typing it the way I see it. Let's put that in parentheses as well, just to be safe. 15. Okay, and then it does get a little bit challenging to keep track of your parentheses. I'm going to close off that one, and this should close off the numerator, right? Then we're going to say divided by the bottom, which is basically 3. Let's just do 3. I think that's pretty safe. Okay. It says round to 2 decimal places, so that's what we get. So let's go with it. This one. So then we got negative 16,384 is 16,384.5. That's exactly what we got. Right? You know, that's what it is, right? Okay. Are there any questions? We're going to go ahead and stop there. You guys have any questions? So while you think about some questions, let me go ahead and make a copy of anything that you saw me writing. I'm going to go ahead and make a copy of it available on Blackboard. This is the fall. This is College Algebra 2. To the notes, updated daily. This is week 11 on Wednesday. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. If there aren't any burning questions, we're going to end the session here. Enjoy your weekend. It's a good idea to come next week with questions. And otherwise, from one beautiful mind to another, take care, guys. Peace. Yep.